So this I shifted with corresponding to some of values. So what will happen? I will calculate these values with my current value or whatever the kernel results what we had. Similarly, I will shift this into the two times. So I will take this one and I will calculate with respect to this. Similarly, I will shift this one like this one. So I will take and I will calculate this one. So further, you can shift this one and this one, so that you will get four cells according to the image you had, 5 cross 5 image. So whenever you multiply with regarding the shift operator with respect to the striding nature, you will get somehow results with respect to this image. So this is very helpful whenever you have some of the images like this. You need to identify some of the patterns according to the images. So we can directly use this function in terms of the convolutional layer you want to be add in terms of padding or striding. So actually we have a formula for this. That is, if suppose you have an n cross n kernel or n cross n input image, you want to be showcased in terms of the output results, or o cross o, you can say. So for that o, you're going to be get n plus 2p. Kernel we can represent it as k maybe. So kernel we can represent it as a k. N plus 2p, 2 padding minus k plus 1 by s. So S is nothing but a striding, and P is nothing but a padding, K is nothing but a kernel, and plus 1 is going to be helpful as an equation in terms of to get output results, to get satisfied. And if you go and see, yeah, this one. So N plus 2P minus K by S plus 1. So number of input features for N out, you can see on output results, and number of the convolutional kernel results, and also the padding, and also the striding results. So we can also learn maybe the max pooling. So I will tell you how does it going to be helpful. So take this max pooling. So you have you have an image, you have done padding and everything. So you're going to be learn some of the layers. So this is the input image. So you have done some of the hidden layers according to your knowledge. This is fine with you. So at the end, what will happen? What will happen? You have converted and applying the every image. Suppose this is having the n cross n input size, and you eventually need something called as array at the end. Hope you remember, just now we've seen that, so that you will get some classifier results at the end. So this is some array kind of the nature. So you have n cross n, but you need something n cross 1. You can see here n cross 1 kind of thing. So only you need one column to represent you having the weights with respect to the image or not. So for that, we're going to be use something called as a max pooling. So we can represent this max pooling in terms of in any kind of the nature. You can say if you're going to be apply this max pooling operation, this is not a layer, this is just an operation with respect to the whatever the shapes, input shapes you have with respect to the hidden layers. So if you go and see this diagram, this is very simple, easy to understand, I can say. So max pooling consists of some input images after completion of your padding and everything. So what will do, it will split it into these kind of the matrix, or any kind of the you can say some kind of the dimensional to split in terms of 2 2 cross 2 or 3 cross 3 or 4 cross 4. So like that, currently it's going to divide it into the 2 cross 2. You can also see. Similarly, the next cells also divided into the 2 cross 2, and the next other cells also divided into the 2 cross 2. So what will happen? Whoever having the max amount of, this consists of the max amount of value. So in these cells, you can see 2 cross, in this 2 cross 2 cells, it's having the max amount value. You can say this contains 1, this contains 3, this contains 2, this contains 9. So whoever having the max value, I'm going to be retrieving the 9. You can see this consists of the 2, this consists of the 1, similarly the 1, similarly the 1. So who consists of the max amount, I will write it as like this. Similarly, this consists of 6, so I will write it as 6. This consists of the 3, so I will write it as 3. So that you can see we have 4 cross 4, it reduces it to 2 cross 2. So like that, you can also apply again with respect to the each and every one. so that you will also get the other matrix. But 2 cross 2 is fine with us with respect to the you can directly apply the flatten layer on top of it. So we'll also explain the flatten layer maybe tomorrow. So flatten layer, if you apply, you will get the matrix kind of the array kind of the thing, so that you will get some idea eventually. So this is going to be very helpful at the time you're going to be learn as a max pooling operations. So yeah, if you go and see some CNN architecture, how does that going to be helpful to understand? And we can also learn maybe the activation functions tomorrow, activation functions and optimizers, and some are the other layers, some are the other layers, like just now we seen as a dropout and flatten, and also some representation with respect to you can say transfer learning kind of pre-trained mechanisms. We had VGG16, XNet, XLNet, and ResNet. So these are a very popular predefined models, and come across with the VGC16 brilliant ideas, I can say, when compared to recent research, whatever they implemented. So according to that, we can also go with some other kind of the nature to understand how does this going to be very helpful in terms of the Python nodes. You can see we're going to be used mostly deep learning concepts as a TensorFlow and Keras, most preferably. CNN is going to be related to two different concepts. One is the TensorFlow, the build they have built in terms of whatever Google, you can say they build in terms of the Google the platforms, and also they're going to be sell some of the products with respect to the TensorFlow, and something called as a PyTorch. So this PyTorch is developed by Facebook. So this they're also building some of the products according to their own API systems, and all a few of them are having open source libraries we can use directly maybe. So these two are very popular to represent any kind of the code in terms of the CNN part. I preferably go to TensorFlow because it is easy to understand when compared to the PyTorch. PyTorch having their own limitations also, and with respect to it's also perform well. It's also computation efficient when compared to the TensorFlow. Both is going to be very brilliant, I can say, but I preferable to learn TensorFlow in terms of avoiding the PyTorch. So currently in this notebook also we preferable to learn with respect to the TensorFlow only. So these are the major steps, I can say, where whatever image data you have to specify to work with, these are some of the standard steps you have to follow. So for that you can see here, so generating a data sets. So what will happen, you have some the first point you can see, so getting some data sets you can work with. What will happen if you have a raw data sets consist of 1,000 images. So your task is to predict, or your task is to classify whether those images consist of dog or cat or tiger or lion or etc. So you have animals data sets, animal image data sets basically. So by using these, you have to be classified with respect to whatever the input images you had. So according to system perspective, it will be learned 1,000 images. It will according to whatever we learned as a classical ML stuff as a tabular data sets. So whatever the 1,000 images we are going to be passing to your training data sets, it will learn patterns, something patterns. But what will happen eventually, it is also occurs some of the cases as a overfitting of the model with respect to the test data sets and underfitting of the model. So to avoid this confusion, and also you will eventually get the good accuracy results. You cannot get the good accuracy results at the time. You are working with only for this kind of the range. So the one of the good idea, good mechanisms to follow up these things to increase your images, to increase your images, to train your model to get to understand some more other patterns to get the good accuracy results. So further, how to get the new images, or how to increase your shapes of the images, this is a one brilliant idea, or brilliant question you can say. So whenever you require to increase your images, suppose you have an image like this. Suppose you have an image like this. So what will happen with respect to increase the any images? What I will do something, we have a concept called data loader. Okay, something called as a data loader. So what will happen? You eventually in the data loader step, we are going to be conducting with respect to whatever the input image, 1,000 input images we had, we are going to be do to increase these input images into 10,000 images by using some operations. So I will tell you what are the different operations we can perform on the input images, something called as rotation. So I will rotate this input image in terms of anti-clockwise direction